Hello viewers, in today's session we are going to discuss another important and conceptual problem from derivatives. And here we have a problem where the greatest integer function is involved. So we have to find the value of the derivative of this function f of x at this point, that is x is equal to square root of 2 pi, when the function f of x is equal to sine, and here we have pi by 2 times the greatest integer of x plus 1 minus x square, if x belongs to this open interval, that is 3 comma 4, right? So let us see how we can find out the value of the derivative of this function at this desired point, that is square root of 2 pi, right? So here we'll simply make use of the definition of greatest integer function to solve this problem, and in addition to this we'll also make use of some concepts from trigonometry. So now let us first try to get rid of this greatest integer function, that is greatest integer of x plus 1. So we can remove, or we can get rid of this greatest integer function here by using this statement, that is the x belonging to the interval 3 comma 4. So x belongs to this open interval 3 comma 4, so we can also write this as x greater than 3 but less than 4. And here we have greatest integer of x plus 1. So x plus 1 can be obtained if we add 1 throughout this inequality. So adding 1 throughout this inequality, we have 3 plus 1, then we have x plus 1, and here we have 4 plus 1. So this is 3 plus 1 4, this is x plus 1, and here we have 5. Now see, this inequality suggests that x plus 1, it lies between 4 and 5. So this is our real number line, and here we have 3 and so on, and x plus 1, it lies between 4 and 5. So the greatest integer of x plus 1 is given by 4, right? So the value of greatest integer of x plus 1 is equal to 4 when x is greater than 3 but less than 4. So now we can replace this greatest integer of x plus 1 by 4. So now we can write the function f of x as a sine. We have pi by 2, and here we can now write 4, and here we have x square. So this is sine, and here we have 2. So this is 2 pi minus x square. Now from trigonometry, we know that sine 2 pi minus theta is given by minus sine theta. So here theta is x square. So we have minus sine x square. So our function f of x is now equal to minus sine x square when x belongs to this interval, that is 3 comma 4. So now let us differentiate f of x. So we have d by dx of sine x square, and the derivative of sine function is cosine function. So we have cos x square, and by chain rule we have to differentiate x square, and here we have minus cos x square, and x the derivative of x square is 2x. So we have minus 2x cos x square as the derivative of f of x. So now to get the value of f prime of square root of 2 pi, let us substitute x is equal to root 2 pi. So we have here square root of 2 pi minus 2 times square root of 2 pi, and here we have cos root 2 pi and here we have square. So now we can write here minus 2 times square root of pi, and here we have cos square of square root of 2 pi is simply 2 pi, because here we have 2 pi raised to half, and then we have the square, so 2 and 2 get cancelled and we are left with 2 pi. Now from trigonometry we know that cos 2 pi is equal to plus 1. So here we have now minus 2 times square root of 2 pi times 1. Cos 2 pi is plus 1. So the value of f prime of square root of 2 pi is given by minus 2 times square root of 2 pi. So this is the value of this expression, that is f prime of square root of 2 pi. Hello viewers, in today's session we are going to discuss another important and conceptual problem from functions. And here we are given this problem where we have two functions, f of x and g of x, such that f of x is equal to signum of x and g of x is equal to x minus greatest integer of x minus 3 for all values of x belonging to the set of real numbers. And further here we are given that the composition of the functions f and g, that is f of g of x is equal to 2 minus natural log of lambda, and where lambda belongs to r, then we have to find the value of lambda, right? So let us see how we can find out the value of lambda using the concept of signum function and fractional part function, right? Because here we have x minus greatest integer of x, and the fractional part function of x is defined as the difference of x and greatest integer of x. So now let us start with this function, that is g of x. So g of x is equal to x minus greatest integer of x minus 3. Now we know that the fractional part of x is defined as x minus greatest integer of x. And we know that the range of fractional part function is given by this interval, that is 0 comma 1. So here 0 is included and 1 is not included, right? Okay, so now let us replace x minus greatest integer of x by fractional part of x. So here we have now fractional part of x minus 3. Okay, so now here we have fractional part of x belonging to this interval, so we can now write fractional part of x, and here we have 0 and here we have 1. So we can also write this expression like this inequality. Okay, so now let us subtract 3 throughout this inequality, because here we have a fractional part of x minus 3. So let us subtract 3 throughout. So we have 0 minus 3, and here we have fractional part of x minus 3, and we have 1 minus 3. So we have minus 3, and fractional part of x minus 3 can now be replaced by this function g of x. So here we have g of x, and here we have 1 minus 3 minus 2. So now g of x has this range, that is g of x belongs to the interval, that is minus 3 comma minus 2 for all x belonging to r, right? Okay, so now let us see this function f of x. Now f of x is given as a signum function. So we define signum function like this, that is signum of x is equal to plus 1 whenever x is greater than 0. Signum of x is 0 when x is 0, and signum of x is minus 1 when x less than 0. So whenever x is a positive number, that is x greater than 0, then signum of x takes the value plus 1, and when x is equal to 0, that is a signum of 0 is defined as 0, and when x is a negative number, that is x less than 0, then signum of x takes the value minus 1. So now so far we have obtained this inequality, that is g of x is greater than or equal to minus 3 and less than minus 2. And we have also defined the function f of x, which is the signum function, like this. So now let us take the composition of f of g of x. Now see, here we have f of g of x. So now we have to calculate the value of f when the input is g of x, right? So here g of x, it belongs to this interval, that is minus 3 to minus 2, and from this inequality we can easily conclude that g of x is always a negative quantity, right? Because for all values of x belonging to r, because g of x has the range from minus 3 to minus 2. So all values of x belonging to r, g of x is going to be negative, right? So this is an important step while solving this problem. So g of x is always going to be a negative number, because it lies from minus 3 to minus 2, and all the numbers which lies in between minus 3 and minus 2 are negative. So g of x is always going to be a negative number for all x belonging to r. So we have to now calculate this value, that is f of some negative number, right? And from the definition of f of x, we can see that whenever x is less than 0, that is the input is less than 0 or it is a negative number, then f of x takes the value minus 1. So in this case we have f of g of x, and g of x is negative due to this inequality. So we have to compute f of a negative number, right? And whenever the input is a negative number or negative value, that is x less than 0, then f of x is minus 1. So f of negative number is minus 1. So the value of f of g of x, that is the composition of f and g, is given by minus 1 for all values of x belonging to r. So now in the given problem, we are given that f of g of x is equal to 2 minus natural log of lambda. So here we have this expression is equal to 2 minus natural log of lambda. So now we have an equation in lambda. So 2 minus natural log of lambda is equal to minus 1. So we have here minus log of lambda is equal to minus 1 minus 2, and this is minus 3, and cancelling these negative signs, we have natural log of lambda is equal to 3, right? So we can also write it like this: log of lambda to the base e, and here we have 3. So from the definition of logarithm, we can now write this statement as lambda is equal to e raised to 3, right? So the value of lambda is equal to e raised to 3.